Imagine you are on a treasure hunt, and after months and months of searching, you have found the lost temple and can finally loot all of the treasure. But as you try to do that, you realize that the chest is behind a huge glass wall. To make matters worse, your arch rival is also there to grab the gold, and he has a giant rock to help him. You only have a marble in your pocket. What should you do to break the glass wall and take all of the treasure? Let's see your rival's plan. If he rolls the rock, the glass will easily break. Can you roll your marble and expect the same thing to happen? That might not work for you, but why? An obvious difference between the marble and the rock is that they have different sizes. To be precise, they have different masses. And the heavier rock is the one that is able to break the glass because it applies a larger force on the wall. What you've just figured out is that the force applied by an object depends on its mass. So using the rock, the glass will break easily and your rival might win. But now the pressure is on you. How can you break the glass with a marble? While thinking, suddenly you have an idea. You check your other pocket and find a toy gun. Would shooting the marble break the glass? This plan might definitely work. But why? Because now the marble would have a much greater speed. A greater speed will result in a greater force on the glass wall, and it would break. From this plan, you've realized one more important factor that affects the force applied by an object: its velocity. If you combine the two things you've just learned, you can say that the force applied by an object depends on its mass and its velocity. What you've just figured out, Newton had discovered a long time ago. He felt that if we combine mass and velocity, we can talk about force and actually calculate it. This gave birth to the concept of momentum. Momentum gives us a better idea about force. Let's see how. For an object with a mass m and velocity v, momentum is given simply as their product. We denote it by the letter P. So P is equal to mv. So the rock had more momentum because it had a greater mass. The marble had more momentum because of its higher velocity. And because of this large momentum, both were able to break the glass. We can use momentum to understand a lot of other things. For instance, ever wondered why a fast bowler takes such a long run-up when he bowls? Long run-ups help him gain velocity. What he's basically trying to do is gain momentum. This momentum helps him bowl faster. This same technique is used in many other sports like the javelin throw. The athletes take a run-up to gain momentum, and this helps them throw the javelin as far away as they can. Now that both you and your rival understand what momentum is and how it works, how about you both break the glass together and split the treasure equally, so everything's fair? I'm sure you're happy you learned these today. Force applied by an object depends on 1. The mass and 2. The velocity. P is equal to mv. Momentum equals mass into velocity.
Mathematical formulation of second law of motion. Second law states that the rate of change of momentum of an object is proportional to the applied and balanced force in the direction of force. Let us formulate second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time t by the application of constant force F throughout the time. The equation of momentum is mass into velocity. Here, in first case, initial momentum is equal to P1 is equal to mass into initial velocity. So, P1 is equal to m into u. Second case, final momentum is equal to mass into final velocity. P2 is equal to m into v. Change in momentum is equal to P2 minus P1. That is final momentum minus initial momentum. That we can write final momentum mv minus mu. Then we can take as m as common, m into v minus u. The rate of change of momentum is m into v minus u by t. According to second law of motion, the applied force is directly proportional to rate of change of momentum. That is, rate of change of momentum is m into v minus u by t. So, the applied force, that is F, is proportional to m into v minus u by t. To remove the proportionality symbol, we want to add a constant k. So, we can write the equation F is equal to, the proportionality symbol is changed, k into m into v minus u by t. It is taken as equation number 1. We know that acceleration is equal to rate of change of velocity. That is, A is equal to v minus u by t. In that equation number 1, instead of v minus u by t, we can apply A. So, the equation become F is equal to k into ma. K is a constant of proportionality. Value of K is 1. So, unit of force we can write F is equal to Km into A, where K is equal to 1, F is equal to Ma. So, the equation of force is ma. F is equal to ma. Unit of mass is kilogram. Unit of acceleration is meter per second square. Unit of force is finally kilogram meter per second square. That is mass into acceleration. That is kilogram meter per second square or Newton. What is 1 Newton? 1 Newton is equal to 1 kilogram into 1 meter per second square. It is the amount of force that produces an acceleration of 1 meter per second square in an object of 1 kilogram mass. Let us understand how Newton's second law is helpful to find Newton's first law. We know that F is equal to ma from second law. A is equal to v minus u by t, that is acceleration. When we apply the value of A to F is equal to ma, the equation became F is equal to m into v minus u by t. For finding first law, we can write F into t is equal to m into v minus u. If we are not applying any external force, that is Newton's first law. If we are not applying any force, that is F is equal to 0. So 0 into t, 0, m into v minus u. So finally we will get v is equal to u. That means initial velocity is equal to final velocity. That means if the object is at rest, finally it is also rest. If the object is in moving or motion, finally it will become in motion. Okay? Summary of today's class. We had discussed about momentum. SI unit of momentum is kilogram meter per second. Newton's second law of motion. Mathematical formulation of Newton's second law of motion. How does Newton's second law is helpful to finding first law? These are the things we had discussed today, and also we have to concentrate some more points related to momentum. That is, more force is required to stop a cricket ball in comparison to tennis ball. Force is required to stop a moving body is directly proportional to its mass. More force is required to stop a cricket ball. Why? With higher velocity in comparison to a ball with lower velocity, there is a momentum varies. Force required to stop a moving body is also directly proportional to its velocity. Read the chapter up to page number 123 times. Thank you.